This instructional video will show you how to use, given information, the percent composition by mass and the molecular weight to determine an empirical formula from the percent compositions and then a molecular formula based on the molecular weight. So once you're given this starting information, you can assume 100 grams of the material, and we do that because it makes converting percentages to grams very easy. 92.6% of 100 is going to be 92.6 grams of mercury. And we look at the periodic chart and find that 200.6 grams per mole is the molar mass of mercury. And when we complete that division, we find that we have 0.462 moles of mercury. We can perform the same operation with our percentage of oxygen. We have 7.4 grams of it and 16.0 grams per mole, which gives us 0.462 moles of oxygen as well. And so the information from this step, namely the numbers of moles for both of my elements, is what I'll be using in the second step. So the smallest number of moles in this case doesn't matter. So we will divide that 0.462 for mercury by 0.462 and compare that in a ratio for oxygen, where we end up doing the same thing. So this gives us a 1 mercury to 1 oxygen ratio. So taking this information allows us to determine an empirical formula. If we had fractions, we would have to multiply that out to get all whole numbers on everything. But in this case, we can simply write an empirical formula that reflects that ratio. So now with this empirical formula, we can determine an empirical weight and compare that against the molecular weight which is given to us. So the molecular weight is 433 grams per mole, thereabouts, and that's going to be equal to some quantity times the empirical weight. And the empirical weight is 216.6 grams per mole. And so the value that we find that would make this roughly true is around 2. So in the final step, we simply scale up our empirical formula by that amount, and that gives us our molecular formula. And you can check to see that this molecular formula has a molecular weight that is sufficiently close to 433 grams per mole that we accept this as the correct value. And so using these 5 steps, you can solve any problem as long as you have a complete percent composition that adds up to 100% and the molecular weight of the actual molecule itself.